Okay, so today kita akan discuss the overall of chapter 5 punya state of matter. So state of matter untuk chapter 5 kebanyakannya soalan tu is weighted around gas, which is banyak calculation. Okay, those are the thing yang you need to focus lah, sebab kalau untuk liquid and solid, most of it are the same thing. You are explaining the same thing just for different application. You just using temperature, kinetic energy and intermolecular forces macam tu. So the first thing ni macam soalan nombor 8 if I'm not mistaken dalam tutorial untuk gas. Okay, so it is between ideal and van der Waals equation. Okay, untuk ideal gas, it should be you guys should be able to remember it is always PV equal nRT. Anything yang kalau dia tak cakap pun it is ideal gas, you should assume it is ideal gas unless it is stated it is not ideal gas. A lot of our calculation, our first assumption is ideal gas, kecuali is clearly stated cakap it is not ideally. Okay, so untuk ideal gas, we only have two condition yang a lot of gas, tak kisahlah gas mana, dia akan behave ideally. Okay, it is at high temperature, and low pressure. So at these two conditions where gas will behave ideally, okay, walaupun in real world lah. Okay, why is the reason at these two conditions where gas behave ideally? Okay, at high temperature. So I jawab in short forms for you untuk buat nota. Kalau nak jawab nanti, please jawab in full answer lah. Okay, kalau macam dia tanya what are the condition of that when gas behave ideally. Okay, so at a high temperature, the reason kenapa it is at high temperature we have high kinetic energy. Okay, at high kinetic energy, okay, those gas molecules are able to overcome the intermolecular forces. Okay, ataupun intermolecular forces become negligible. Negligible. Betul ke saya eja negligible? Okay, korang eja lah negligible betul-betul. I think masalah eja. Tak sure. So, another condition where it is behave ideally is at low pressure. Right? At low pressure. Yang kurang ni. Masuk cepat sikit At low pressure is the gas is far apart as possible. Okay? As far apart as possible so that dia punya volume is negligible. Okay? Volume of gas is negligible. Okay. Also, when it is far apart, it is also you boleh use the same arguments where intermolecular forces are negligible sebab the molecules are far apart at low pressure. Okay. Untuk ideal and van der Waals forces, kalau disuruh explain, untuk kalau macam alamak you tak ingat or you don't know how to start, this kind of question, easy way untuk you start and you secure at least 1 mark. Okay? At least 1 mark is you tulis dia punya equation and label apa dia punya all of those unknowns. Okay? So let me draw. So untuk ideal gas, it is PV equal nRT and van der Waals is P plus N squared A over V squared, while V minus NB equal nRT. Okay, so untuk dia suruh cerita pasal ideal gas, dia suruh cerita pasal van der Waals equation. You can get first mark is by doing this, and then you labelkan what is P. So this pressure, volume, moles, gas constant, temperature. Okay, remember. Okay, kalaulah dalam Charles law, which is we ada calculation involving temperature kan, that one is okay, we can use Kelvin or Celsius. But in ideal gas ataupun van der Waals, the temperature always in Kelvin. Just remember, you always use Kelvin. Okay, pressure and volume depends, you can use either way because we can use different gas constant kan. Okay, untuk van der Waals equation, the only things yang different is we have A and B, okay, which is dia punya gas constant, right? It's not sorry, it's not a gas constant. It is a constant to fix the pressure and the volume. Why we need to add this component? Okay, because apparently in real world the intermolecular forces are not negligible. So okay, in real gas, we have intermolecular forces, right? So contohlah here, so intermolecular forces will tarik those gases together, right? Have forces between those gases. So when your gas molecules are moving, okay, a pressure is created bila those gas molecule hit the walls of your container. That is pressure, right? So bila dia nak hit the wall, on the way dia nak hit the walls, dia ditarik oleh other molecules. So you punya pressure real is lower than pressure ideal, right? Okay, so it makes sense. And then volume, apparently volume real juga, volume real is also less than volume. Okay, so kenapa? Sebab apparently gas also has volume or space yang dia occupy. When designing the ideal gas law, diorang just imagine like these gas molecules are very small, it is negligible. So diorang anggap dia tak ada je. Right? So this equation is to show that you nak correctkan the ideal gas law is by having a less pressure and less volume. Okay. Very simple enough. Volume for the volume real is volume ideal tolak and the number of moles and B. Okay. So it makes sense untuk dapatkan volume yang rendah kan. Okay. Tapi kenapa pressure is you tambah the number of moles squared times A over V squared. The reason is A is negative value. Kenapa it is negative values? It is because it is an attractive force. Okay. So it is a constant untuk measure how attractiveness of the forces. Okay, how strong the force, intermolecular force tarik each of the molecule. So lagi stronger the forces, lagi kuranglah pressure dia kan. Okay. So is everyone clear with this so far? It's just that between ideal gas and van der Waals. Okay. Kalau comparison, the thing yang you need to cerita is you cerita the assumption lah. Pasal pressure, pasal kita assume pasal dia punya kita assume pasal dia punya intermolecular force. Kalau mana ideal gas kita assume intermolecular force tak ada kan, kita assume it is negligible. Okay, and also kita assume dia punya volume also the same, negligible. Tapi in real world, those will take effect. Those will make the gas behave differently. Okay, so do you have any question between ideal and van der Waals equation? Ada tak? Kalau untuk jawab, you also boleh lukis tau. It is okay untuk lukis and you show that the arrow macam this is the attractive intermolecular forces. You boleh tunjuk. Okay, it just okay. Cara you nak jawab, try to jawab as much as possible so that contohlah you ada salah satu, kalau pemeriksa tu baik hati, they can give you, oh okay, since they show a correct concept, you can be given a marks like that lah. Okay, do you have any question so far? Okay, soalan pertanyaan semua okey ke? Okey tak? Okey tak korang? Okay, right. Okay, so after this kita akan tengok on past paper. Right, so this is type of in 2003. Okay, dia bagi the value of the van der Waals constant, dia bagi value. Okay, lepas tu untuk gas W, X, Y and Z, and soalan dia tanya deviate the least from ideal behavior and has higher boiling point. Aduh, saya tak boleh cakap pergi. Okay, so untuk exam, it is very advisable untuk bawa highlighter. At least kalau boleh banyak color pun tak apa. The reason is, at you jawab, okay, sekarang boleh lah saya point out, you nampak it is deviate the least. Kalau dalam exam, you are rushing and you are baca cepat-cepat, you nak jawab as fast as possible before the times run out, kan? Kalau tak salah, it's still 2 hours you ada time yang you untuk jawab. I think it's 4 question. Okay, untuk this, baca betul-betul where kalau sekali pandang you akan baca je is deviate from ideal gas behavior. While the question tanya is deviate least, maksudnya paling kurang deviate. In other words, the question is actually is dia tanya gas mana yang the closest behavior to ideal gas. That is the real question. Tapi it put it in this way to trick people who baca cepat-cepat and miss a point. Okay, and then has a higher boiling point. Okay, so apa benda yang actually kita nak tengok from this? Apa yang dia boleh dapat from the constant? Right? So let's tulis balik the formula, which is P plus N B squared darab dengan V minus NB equal nRT. Okay, so from this They nak deviate the least from ideal gas behavior, and they give the value of this and this. Alright. Actually, the only thing yang you untuk dapat all the information you can dapat from okay. The A value. What is the significance of A values comparing to the B values? Let's look on B value first. Kita guna B value ni untuk fix apa? Apa yang kita fix untuk B value? Kita betulkan from the ideal gas, B value tu kita betulkan apa? Yes. So, volume. Kalau kita betulkan volume, it means that it just B tu, right? B2 is just a constant to measure how big is the molecule lah kan? Does it make sense kan? Just to measure the size of the molecule. Okay. Measurement. Oh, okay. It makes sense because the higher the B value, maksudnya the molecules are bigger, so it need a bigger correction lah kan. So kalau B besar, it means dia punya volume akan be less lah sebab the molecules occupy more volume. Okay, the actual significance this is coming from A, where actually A is trying to fix the pressure. Okay. Apa ni? Okay. Apa benda yang kita guna untuk fix pressure? Untuk jadikan dia balik a real pressure. Okay. So we have moles. Moles does not do anything. Volume does not really do anything. Just a calculation. They don't find out. A, what is the significance of A? Okay, apa yang affect pressure? Pressure is affected by what? Tadi I lukis the container tu kan? Apa yang greatly affected pressure? Kenapa pressure dia kurang? Yes, it is an attraction intermolecular forces, right? So the significance of A value is a measurement. Okay, don't worry, this soalan you guys tak perlu salin. Nanti saya akan bagi a copy of soalan ni. Ada dua je soalan yang saya akan bincang today. So don't worry. So it is a measurement of intermolecular force strength. Okay. So I'm asking your opinion. Strong intermolecular forces ke weak intermolecular forces yang akan become ideal gas? Okay. Kalau intermolecular forces yang kuat ke ataupun yang weak? Which one yang the gas will behave ideally? It is weak. Okay. Because in ideal gas, remember ideal gas, kita punya assumption is intermolecular forces is negligible. Okay, kita macam tak pandang pun intermolecular force. Kita bayangkan the molecules zoom past each other without any attraction yang slowing them down. So the less intermolecular forces, the more it behaves ideally. Actually, untuk jawab soalan A, it's just that you are finding the lowest A constant, which is W. So, you punya dapat W. Do you need explanation? Tak perlu explanation. Kenapa? It's only 2 marks. Okay? 2 marks. Ada 2 soalan. So, it's 1 marks each. Kecuali, dia ada 2 soalan, dia bagi markah 4 marks. Then you have to give your punya answer and then you give you punya explanation. Okay. You don't need to tulis everything yang you know, because you need to save time untuk jawab soalan lain, soalan yang lagi susah yang perlu you fikir. Soalan yang macam ni, just okay, the lowest A value W. So this is you punya answer, and terus dapat marks. Okay. And then, which has the highest boiling point? How does something boils, right? So example like this. So example, this gas as liquid lah. So jangan duduk. Okay. For them to boil, for the gas bubble to form in between those molecules kan, those air bubbles yang form and pop dekat atas tu, it means that the molecules need to spread far apart untuk create this empty space for the gas bubble to form kan. Okay, what are the factors yang affecting those molecule from spreading far apart? Apa yang menyebabkan dia orang susah ataupun senang untuk spread them far apart? Okay. Saya kena tanya banyak korang soalan. Aku tak korang mengantuk pagi ni. Shit. Please. No internet? What do you mean no internet? Ayah. Okay. Hello. Korang ada ke? Tadi saya terputus. Dekat mana saya terputus? Masa higher boiling point tu, korang dengar ke? Ataupun dah terputus dah? Okay. Ayo je. Tepat je you punya kiraan. 45 second. Okay. Alright, so sekarang okay kan? So I wanna continue on higher boiling point. Okay. So untuk higher boiling point, right? What for a liquid to boil? For a liquid to boil, it means that the molecule need to spread jauh-jauh so that bubbles can form, and those bubbles is the vapor of the liquid, which is dia punya gas, and akan rise atas lah sebab it's less dense than liquid. So apa yang the reason yang restrict the molecule from spreading far apart? Apa yang menyebabkan dia senang ataupun susah for this molecule untuk bergerak jauh from each other, untuk bergerak? So what is the factor yang affecting those molecule untuk bergerak? Mana korang sini? Yes, good. So it's also IMF, intermolecular forces, because these molecules are attracted to each other. Tapi in liquid, since they are closer, it's not only attracted to the other tempat, they also attracted to the closest one kan. So kalau boleh, these molecules tak nak gerak. So it's a bit harder untuk diorang move far apart from each other. Sebabnya dia orang tertarik to each other. Everyone wants to clump together because dia orang ada intermolecular forces. So it means that kalau intermolecular force yang weak, it will be easier for them to boil lah kan. And kalau intermolecular force untuk higher, it means it's harder for the liquid to boil. Okay, so actually in this question you don't even have to look at B. Okay, the only thing yang you need to look on is A, which is the factor yang the measurement of intermolecular strength. So it means that the higher A, the higher is the boiling point. So straight to the point, you punya answer should be Z. That's it. Okay, it's 2 marks. So everyone clear so far before kita masuk phase diagram? Kalian okay? Korang okay kan? Ni bukan korang. Mana korang? Okay. Okay. So, phase diagram. Sekejap, mana? Okay, in dalam chemistry, anything yang involving gas pula, graph, we have two things. Soalan dia ada dua type of question yang dia akan tanya. So, kalau pasal graph, dia ada, okay, plot ataupun sketch. So, you have to. Untuk this kind of question, is either dia akan ask to plot the phase diagram ataupun sketch the phase diagram ataupun any graph. Contoh macam hari tu yang titration, dia suruh plot the graph. Ataupun yang pressure hari tu, yang pasal Bose dengan Charles Law, dia suruh plot. Okay. Kalau plot, you need graph paper. Need graph paper. Which is, you need to draw the full on graph lah. Macam fizik pun korang draw graph kan. Like that. Kalau sketch, you can just draw and make sure you draw neatly. Dekat you punya answer sheet. Just draw neatly dekat answer sheet you. Which is bawah you punya question lah. Terus draw je atas kertas kajang you tu. How big, how small your drawing, it should, okay, untuk sketch, it should just enough, okay. Kalau besar, you just waste time kan. It should be enough where all of your information dekat sini, title, all you punya graph ke, macam tu kan. It should be visible and senang orang nak baca. Kalau contoh you nak label ke apa, should be visible and senang. Because kalau kecil sangat, kalau you label, contohlah graph you besar ni, macam tu, dan you nak kena label, pemeriksa will not count because dia akan anggap macam dia tak nampak. Itu je. Okay. So, at least, okay, you buat you punya tangan, besar tu. You buat L guna you punya jari dalam besar tu, it is acceptable lah. Okay. So, dalam sebesar jari you bila you buat L. That is acceptable. So, in this phase diagram, we only have two type of phase diagram. And the way kita draw, any graph, tak kisahlah sketch atau plot, the three main things yang you need to have is, first of all, axis. Okay. Axis should be straight. Jangan jadi malas macam saya tak guna pembaris. Guna pembaris. Okay. And then the second thing is you label the axis properly. Okay. Untuk phase diagram, for the y-axis, it is pressure. Okay. Never just label it is as P. Okay. It will not be counted because diorang akan just bayangkan macam diorang tak tahu what is P, right? So you need to write in full. So it is pressure. Okay. Lepas you tulis pressure, okay, diorang pemeriksa dah faham you are talking about pressure, but they will still do not know what unit of pressure you using. Unit is also required, 100% required. Okay. And then you punya volume. Untuk phase diagram is temperature, sorry. Temperature. And also the unit. Okay. Untuk phase diagram, we usually use degree Celsius. Okay. O black atas. So that is the two things. So axis, pressure, and then also another important thing dalam you punya graph in lab report bersama is you punya title. So it is a phase diagram of apa-apa. Contohlah soalan tu tanya CO2 ke H2O, itu tulislah. Okay. Untuk phase diagram, it always have three component of the graph. It is not graph yang linear. The very first thing is, okay, you do not need to draw like accurately every time. As long as the shape is fine, shape is correct, your marks can be given. So how to draw it? You have a small first curve, okay, and then we have a bigger second curve, right? That is every phase diagram akan ada these two curve. Right? The only thing yang different is we have two different type of curve. So we have a negative slope and we have a positive slope. Okay. Sorry, this is positive, this is negative. So this negative slope is for H2O ataupun anything yang boleh buat hydrogen bonding. Okay. Another example itu saya bagi tahu is ammonia, NH3. Okay. NH. While this is usually, excuse me, soalan akan tanya pasal carbon dioxide. So soalan akan tanya pasal CO2 ataupun any other gases. Every gases yang selain yang tak boleh buat hydrogen bonding akan have this kind of slope. Alright. So remember that you punya start of the graph never start dekat kosong. Dia start dekat around tengah sikit, atas sikit and not tepi langsung. Dia macam graph ni is floating. It does not touch anything. So untuk phase diagram, another thing yang always the same juga is this lower part is gas, this is solid, and this is liquid. Okay. Bawah gas, kiri solid, atas liquid, always the same. And then another thing yang you need to label is we have 2 points. The only 2 points yang it is important. Where it is color apa color. Okay. So we have this point and this point, where this is the triple point, and this is dia punya critical point. Critical point. Okay. Untuk the phase diagram, the you punya marker akan ada for the correct axis and label and unit. Okay. You punya title, and then you punya correct graph, and also you punya correct labeling. By correct labeling does not mean just these two. Is you correct the labeling critical point, triple point, gas, liquid, and solid phase. Okay. You punya graph, maka you akan dapat daripada you punya bentuk graph and also the correct slope. Okay. As long as you punya the graph look okay, is okay. So draw cantik-cantik, but it does not mean that you have to spend 30 minutes make it the prettiest graph ever. Okay. So the kind of question yang diorang akan tanya is diorang akan bagi table. Mana ni? So this kind of question. Contoh soalan nombor 14. So define critical and triple point. You boleh cari, okay, dalam my lecture note pun dah ada. So the type of question is dia bagi a table. Dia bagi the point that is triple point and critical point, right? And they give dia punya pressure and temperature. So the question is to sketch a phase diagram for carbon dioxide, right? I hope you guys can see. So same thing macam tadi. Okay, so you draw the axis using ruler. Jangan jadi macam saya. Okay, and then you label dia punya dia punya axis pressure. Okay, and tengoklah from the table dia bagi ATM. Okay, just in case kalau dia bagi pressure in Pascal, you also need to draw in Pascal. Okay, follow the information given. Does not necessarily you punya graph, you punya phase diagram always kena bagi pressure in atmosphere. Okay, and then temperature in degrees Celsius, and then dia punya title. Okay, it is a phase diagram of CO2 ataupun carbon dioxide. Okay, so jangan pening-pening about the apa point. Okay, jangan terkejut, alamak dia bagi data that you need to plot a graph. No, nampak tak dia cakap sketch. It means that you draw accurately, but tak perlu draw guna graph. So you draw the slope, okay, and then we have the slope, right? So apa yang you need to label is you label it is liquid and gas. Okay, and then dia punya triple point, you need to draw a dotted line to show dia punya value. And once again guna apa benda dah, guna pembaris. Okay, jangan guna jangan macam saya ni. Alright, so at you punya triple point, dia punya pressure is 5.2, and dia punya temperature is -5.7, while on dia punya critical point it is 73 and it is 31, like that. Okay, jangan cuak or anything. It is -57, it should be on the left side. Does not tak perlu. Okay, untuk the scale for sketching graph, it is not necessarily you have to be exact. Okay, you are sketching a graph, you are showing the shape of the graph. Okay, so this is the phase diagram. Okay, the type of question is dia akan selalunya tanya macam ni lah. Explain the phase change that could possibly occur. So maksudnya dia akan bagi a condition, and dia akan tanya apa phase yang akan jadilah, apa yang akan tukar. So kita akan tukar color. Color yang cantik. Purple plum. Okay. So dia cakap enclosed vessel under 1 atm pressure, 1 atmospheric pressure and temperature of -78 degrees. So -78 dekat mana? Kiri or kanan? Ni or kanan? Baik anak-anakku, kiri or kanan? Sini or sini? Mana korang? Okay, tak perlu label kosong. No need to label kosong.
Kiri.
Yes, very good, kiri. Remember negative. Mana dia pergi? Oh no, dia hilang. Okay, ada balik. So you should label starting from kiri. So you should know that it is in this area. Okay, and then dia cakap pressurize isothermally to 10 atmosphere. Okay, following isobaric heating to 20 degrees Celsius. Okay, the two thing yang hari tu kita belajar is isothermally. Iso means the same. Thermal maksudnya it is constant temperature, while isobaric, it means the same pressure, constant pressure. So you can pick a point yang does not look ridiculous. Okay? Point yang you guys rasa it will make sense. Tak perlu tepat. So let's say this is -78, and it is from one atmospheric pressure kan. So kita can imagine this is 1 atm. So label dekat you punya phase diagram. So for example this, and then dia cakap pressurized isothermally to 10 atmosphere. So you just draw isothermally to 10 atmosphere, and then isobaric heating to 20 degrees Celsius. So isobaric means the pressure will still the same, it still be 10 atmosphere dekat sini. So maksudnya they keep constant tapi they heat those heat dia punya CO2 tu kepada 30 degree 20 degrees. So like that 20 degrees. So dia punya phase change yang you should cerita, it is from gas dia pergi ke solid and then back dia pergi ke liquid. Itu cara jawabnya. Okay. And one thing untuk cara jawab is you should note that here and here, every time dia across a line, it means that it is in equilibrium. So dia starting at gas, lepas tu it went at equilibrium where the gas and the solid are in equilibrium. Salah my arrow. Is in equilibrium dekat this point, and then you become total solid dekat this area, and then at this point it is solid in equilibrium with liquid. Okay. This is equilibrium punya ni lah symbol, arrow. Nanti kita akan belajar on chapter 6, but just know that this is equilibrium punya symbol. So you just cerita point by point. So you punya point yang you akan cerita is 1 here, satu bullet point, and then second, and then sini is you should be the third. Just you cerita is just becoming solid, and then here when dia dah heated isobarically, at this point it should be solid and liquid. So you nak bagi tahu, maybe you nak bagi tahu the position is you can bagi tahu more than negative 57 degrees, sebab kan dekat sini kan triple point. Kalau you rasa macam pening lah nak bagi tahu dia more than negative 57 ke apa, you draw. Okay, you draw this yang my purple line, and then you labelkan A, E. Okay, so you draw, you cerita pasal A, you cerita pasal B, you cerita pasal C, pasal D, and you also cerita pasal E. So you should have 5 points. One more thing yang I lupa nak label tadi is triple point and also critical point. Okay, so everyone okay with phase diagram ke? Any question about phase diagram? Either kalau okay, just remember all this point that you need you punya axis with label and okay. So if according to lecture note, at 1 atmosphere it is negative 78. Okay, those measurement you don't need to hafal, tak perlu hafal. Based on the question, kalau soalan tu the table dia cakap 1 atmosphere is negative 78 atau negative 75 ke, you should you should follow the question. Okay, so don't worry, the question will give you the table, right? Before kita masuk, so it is kalau you nak tahu macam where exactly this type, so it is based on you punya drawing. It is okay where you start. Okay, so I will go on to the question yang soalan yang banyak keluar for chapter 5, which is involving gas. Okay, especially on Dalton's partial pressure punya law. So here, this question 16 on 2005. Okay, soalan macam ni, okay, kalau you tengok, soalan dia pendek tapi dia bagi 7 marks. Don't worry, be happy because there's a lot of marks for you to gain lah. Okay. So, remember, I always cakap, in you punya exam, always bawa highlighter. We need to highlight the information. So, dia cakap 500 ml of vessel. So, dia punya volume containing 1.35 grams of chlorine gas. Dia dekat pressure 76 millimeter mercury punya pressure. And then dimasukkan high oxygen gas, where the gas pressure rises to 565 millimeter mercury. Alright. Then assume that the gas do not react. You nampak gases do not react. Terus tulis kalau gases yang tak react di dalam the same vessel, you can already apply Dalton's law of partial pressure. Okay. And then another thing yang you boleh tengok is, okay, which is other and the temperature remain constant. Apa yang temperature remains constant? Okay. One thing yang you guys boleh ingat, so apa yang law yang temperature remain constant, you boleh ingat Boyle's punya law. So Boyle's law, and dia punya apa formula is P1 equal V1 equal P2 2, right? Okay. Dalton's partial law of pressure. Okay, so this is a technique untuk jawab apa yang you nampak, and the first thing yang you keep in mind, contoh Dalton's law of partial pressure, you tulis all of the formula yang you tahu. Okay, so Dalton's law of partial pressure is pressure total is equal to pressure A tambah pressure B ataupun subsequently ada berapa banyak gas, the total pressure is equivalent to each of the partial pressure. And also one formula yang selalu a lot of people lupa about Dalton's law is that pressure of contohlah pressure of contoh pressure A is equivalent to dia punya mole fraction of A times pressure total. Okay, so mole fraction itu kita dah tengok, which is mole fraction is X A equivalent to mole of A over N total. Okay, so this is the best way untuk you guys jawab any question. So you muntahkan all the thing yang you know, but doesn't necessarily you akan guna semua ni tau. It's just a thing yang you know, right? Okay, so now another technique untuk jawab this kind of question, dia tanya calculate the mass of the oxygen gas. Okay, macam mana from this information you nak dapatkan ke mass? Don't worry, okay? But you should already have an idea. Mass you boleh dapat daripada moles, so you may able to find dia punya mole, kan? So another thing yang you boleh buat is like this. And pen. Okay. So you lukis balik apa soalan tu cakap. So dia cakap it is 500 millimeter of vessel. Or this vessel, which has the volume of 500 ml, right, containing chlorine gas. So containing chlorine gas, mana chlorine gas? So containing chlorine, oh tak nampak, sakit mata saya. Hijau lah. So chlorine gas, which is 1.35 grams, and also a pressure of 760 millimeter mercury. And then ditambah oxygen gas are injected to this. Oxygen gas are injected to this, where now after the oxygen gas are masukkan, so after dimasukkan, P total, okay, total pressure dah jadi 865 millimeter mercury. Okay, so it means that you have two gas yang tak react in a beaker, where bila the total pressure dah jadi 865 millimeter mercury, and you already have the punya volume. So first of all, kita dah boleh eliminate the information yang kita tak perlu. Temperature remain constant means nothing to us, because untuk Boyle's law kita tak boleh apply. Mana my cursor? Boyle's law terus tak boleh apply. Why? What's the reason? Untuk Boyle's, Charles, and Avogadro, okay, only involving one gas. Okay, untuk these three laws, and also ideal gas, PV equal N. Kita kenapa dia only involve one gas? Sebab benda yang bertukar is only dia punya, contoh, pressure bertukar, volume bertukar, temperature bertukar, like that. Okay. So since we are having two gases, we already know the relevant information that here is the Dalton's law. Okay. Perlu guna. So first thing first, okay, kita nak cari dia punya mass. So mass, just kita perlukan dia punya moles. Kalau kita tahu moles, quite easy kan, kita nak cari dia punya mass. Kita boleh darab dengan molar mass. So untuk tahu dia punya moles, macam mana nak tahu? Just kita boleh dapat daripada the mole fraction. So kita boleh dapat daripada mole fraction. And total, don't worry, kita boleh cari, sebab kita boleh dapat gas chlorine ni, kita boleh dapat dia punya moles. Okay. Moles chlorine should be equivalent dengan 1.35 bahagi dengan molar mass of chlorine. Okay. So you should be able to dapat. Okay. Untuk dapatkan mole fraction, mana formula yang ada mole fraction is here. Okay. You have pressure total, which is here, tapi kita tak ada pressure oxygen. Okay, pressure oxygen kita tak ada. So, apa yang kita nak, mana nak dapat pressure oxygen? Which is daripada pressure total. Okay, pressure total tolak pressure oxygen, equal pressure oxygen plus pressure chlorine. Okay, so that is the step by step. So, you identify apa yang you nak, okay, apa yang soalan minta, and then you backtrack. Okay, so from the mass, macam mana you nak dapat mass? Moles, mole fraction, partial pressure, and then total pressure. So now kita dah tahu. So that's why it's 7 marks. Actually, it's quite simple. The 7 marks most of the time is from you punya mental gymnastic untuk patah balik and cari. Okay. So, hilang lagi my cursor ni. Okay. So, let's answer the question for real. Okay, to answer sekali dengan saya. So, untuk pressure total is equivalent to pressure oxygen gas plus pressure chlorine gas. Okay. Remember chlorine ke apa ke, kalau gas is always dual atom So since kita tahu pressure total, it is 865 millimeter mercury is equivalent to pressure O plus pressure dah tahu. So pressure chlorine is 760 millimeter mercury. So pressure O2 you should dapat 105 millimeter mercury. Okay. Don't be discouraged by the unit. Okay. You tak perlu tukar lagi unit dia. Why? Don't worry. Unless you guna this, okay, you guna this law ataupun ideal gas law, you need to use SI unit ataupun depend on dia punya ideal gas law punya unit lah, you punya gas constant. Tapi untuk partial pressure, you can keep the unit. Okay? The reason I tak nak you tukar the unit is takut you make careless mistake dari awal you tukar unit and then jawapan you akan salah nanti. So avoid careless mistake nanti. So here, so we have partial pressure of oxygen 2. So and then partial pressure of oxygen 2 is equivalent to mole fraction of O2 darab dengan total pressure total. The reason why, because nanti dia akan cancel out each other je lah. So you don't need to tukar the unit. Sebab nanti kita ubah this ni, so dia akan cancel lah millimeter mercury. Okay, you tahu kan titik ni bukannya titik perpuluhan, it means that darab. Okay, so tapi untuk cari mole fraction of O2, kita perlu tahu most of O2 and also most of total. So kita still tak complete dekat sini. So let's find dia punya number of moles of TL dulu. Sebabkan XO2 is equivalent to number of moles of O2 over number moles of O2 plus number moles of chlorine gas. Kita tak tahu chlorine gas. So let's find chlorine gas punya moles. And Cl2 is equivalent to 1.35 over 71.0. Okay. Gram per mole. This gram. Alright. So you should dapat is dia punya number of mole is 0.019. Okay. Lebih apa? So kalau you guys tengok, it is 71. Sebabnya chlorine ada 2, bukannya ada 1. Okay. We have chlorine gas, not chlorine atom. So daripada ini you dah dapat the number of moles of chlorine punya gas. Unless kita nak guna color biru. So you boleh cari dia punya number of moles of O2. H. Okay. So the pressure of O2 is equivalent to number of moles. So kita masukkan terus mole fraction kita masukkan terus je lah. NO2 over NO2 plus NL2 and darabkan dengan pressure total. So we are trying to find this, tapi kita dah tahu we know that ini kita tahu. So kita bolehlah cari the number moles of O2. So masukkan. So pressure of O2 is 100 mercury. You tak tahu this 2 and then NO2 plus dengan dia punya moles of chlorine gas 0.019 moles and darab dengan pressure totals which is 865 millimeter mercury. And you should know untuk tukar sendiri, tukar balik, tukar kiri kanan depan belakang semua korang buat tu. And jawapan of NO2 moles of oxygen gas should be 2.62 times 10 to the power of negative 3. So from the moles you dah boleh, lama dah lebih masa. So, from the number of moles, okay, mass is equivalent to number of mole of O2 darab dengan dia punya molar mass of O lah kan. So you darabkan. So you should darabkan dengan O2 which is 32 lah kan. Sebab kan oxygen is 16 and oxygen ada 2 mass of. So you should have 2.6 times 10 power negative 3 mole darab dengan 32.0 gram per mole should be equivalent to, dia punya jawapan is 8.38 times 10 to the power of negative 2 grams. So this is you punya final answer. Okay, kalau you tengok dia punya jalan kira is sini, sini, sini. It's mostly 3 parts, tapi it's 7 marks. Okay, because this is the type of question where you have to think lah. Okay, you have to figure out the information and you need to tapiskan information yang useless, yang membazir masa you. Like 500 milliliter of vessel absolutely means nothing to you. Okay, so everything clear so far ke? I'll pass this, nanti I can make it as a PDF and hantar kat korang. Okay. Because after this korang akan bercuti selama seminggu kan, before kita jumpa. Okay, if there's nothing, there's no question, I'll stop the recording.